Okay, let's see this problem, 3 sum. The problem statement is actually very simple. You are given an integer array, okay, and you have to return all the triplets, okay, such that suppose if this is the array, right? If we add any 3 numbers in the array, it has to add up to 0. Okay, so if you take this array, if you add -1 and 2, it will add up to 0, correct? And if you add these 3, right, -1 1 and 0, it add up to 0. So all the triplets which add up to 0, and this index, right, I, J and K, they all should be different. Okay, and all these triplet we need to return in one array. Okay, this is how the output format. Okay, and then the output, you should not contain any duplicate values. Okay, so this is the this is what we need to return. This is the input. You need to return all the triplets in the array. On the all the triplets, if you add it, it has to add up to the sum 0. Okay, so let's think what is the logic we can use. Okay, so a brute force approach would be, right, okay, you have to check all possible triplets, right? All possible triplets, and then you have to, I think you have to loop thrice, right? Loop 1, loop 2, okay, and loop 3, loop thrice, and then you will get all possible triplets. Okay, loop 1, loop 2. Loop 1 is, let's say I, it goes from 0 to till the this point, okay, which is 0 to len minus 2. And loop 2 is j, it will go from I plus 1, right, from here. I starts from here and j starts from here, and it will go through your len minus 1 till here. And then your k will start from j plus 1, and it will go through the last one, right? So in this loop, if you see, right, there's a loop inside loop, right? So the ijk will give you the all possible 3 values, right? And then you add the values in this index, and then if it adds to 0, okay, you can add it to your output array. But before adding, you need to check already the number exists or not. Okay, for that you can just sort the triplet and store in a dictionary. If it is already there, you need not add it. Okay, this is the kind of a brute force approach. So this is obviously in order of n cube. It will work, but the problem is it will not work within the given time. Okay, so some test cases will fail. So what would be the other approach? So the next approach would be is, let's have a kind of, so basically instead of order of n cube, obviously we can sort and do something, because when you sort, the time complexity is n log n. So first we can sort it. So the first point is to sort it. After sorting, how this array will be? This array will be like something like this, right? It will be like -1, comma -1, comma 0, comma, oh no, -4 is here. -4, -1, 0, 1, comma 2. So it will be sorted like this. Okay. Now you have 3 pointers. You need to add 3 items. So you need to have 3 pointers. Okay. So let's put this is the first pointer. Okay. And keeping the first pointer, right, we have to find all the, don't move the first pointer. This is, they have the second pointer here, have the third pointer here. Okay, so this is sorted, correct? So you add all these first, second and third pointers. Okay, suppose if the value is greater than 0, which means it is big, right? So the third pointer you can move back here. Okay, suppose the value, if you add all these index and the value is less than 0, then means what? You have to move your second pointer forward. Okay, so once if all the value add up to 0, then probably that is your triplet, and once you find the triplet, you add it to your result array. You have your result array, okay, and you add to it, okay. Now, once you have added, right? Suppose let's say that your second pointer came here, and then your third pointer came somewhere here, okay, and then you add it and it became 0. Let's assume that, okay, your first pointer is here, second pointer is here, and your third pointer is here. You add everything, it comes up 0. So now what you have to do is, obviously, once you add it, you have to increment your second pointer and you have to decrement your third pointer. Okay. Now, once you increment your second pointer, okay, then after increment your second pointer, right, you have to check whether the previous value is same or not. If the value is same, you need not run this logic again for this value. Okay. So, for example, right, suppose the second pointer is here and your third pointer is here. Okay, and now your first plus second plus third all add up to 0, and you have incremented your second here, you have decremented your third here. Okay, now this is -1 and your previous number is also -1. Okay, so obviously, right, suppose -4 -1, okay, there will be only one number is possible, right, which is 5. If you add this, it will become 0, right. Let's assume this is 5, okay, and this is already added, correct. So you need not add again. So when you move the second pointer, if the value is same, then you need not run this logic again, because there will be only one other value which is already added. Okay, so until you find a new value, right, you keep on moving the second pointer. Okay, so keeping the first pointer, you are finding all possible three triplets which will add up to 0, and you have added in your result array, right. So this is one thing. Okay, once done, right, let's assume this is the array, right, -1 -1 0 5 and 2. This is the first pointer. Keeping this, you have done everything. Now move the first pointer here. Okay, once you move the first pointer, check if this is sorted, right. So this is first, right. If this number is greater than 0, there is no point in continuing it, because once it is greater than 0, add any number after that, it's not going to be 0. So once if it is greater than 0, you can break, come out of your logic and return the result array. And second one, if this number is same as this number, in case, right, if, suppose this is also -1, this number is same, then there is no point in running the logic again, because for -1, all possible triplets you have already added. When you did here, right, all possible triplets is already added. So if the next value is also the same as the previous value, don't run this logic, just continue and go to the next value. Okay, so this is a logic we are going to follow. Let's see the code. So the first one is the result array apport, and then first thing you have to sort. Okay, and then I am going to have 3 pointers, right. First pointer. Okay, this first pointer, this enumerate of the array which will give you both index and the value. So A is the value, I is the index, right. So initially for this array, right, let's assume the array is -1 -1 -1 0 5 and 1. So the index value I will be 0 and the A value will be -1. Okay, so as I told you, the first check, if it is greater than 0, there's no point in adding other numbers and all, right. So let's come out of the loop. Okay, this is the first step. Okay, and this step, right, this is applicable only for from the second item. So this is applicable only when I is greater than 0. For the first item, it is not applicable, right. Okay, so for the first item, what we are doing here, as I told you, For the first item, you are having two other pointers, right? So this is the first pointer, which is within 0. The second pointer will be your, what is the value coming here? Plus 1. That is I plus 1, right? The second pointer, L is your second pointer actually, which is I plus 1. And other pointer will be in the end, which is your len minus 1. Okay. So until you find the triplet, right? If you add all the thing, if it is greater than 0, I told you, you have to reduce the last pointer, come back here. And if it is less than 0, you have to increment your second pointer to the right side. Okay. Else means what? It is equal to 0. If it is equal to 0, you can just add it to your result array. What value? Your value, the second pointer value and the third pointer value. Once added, increment your left pointer and decrement your right pointer. And once you have done this, right, suppose your L is here and R is here. If L is same as the previous value, as I told you, then you need not run the logic again until you get a new L. Okay, until your previous L and the current L is equal, right? You keep on incrementing the value of L. So you have to get a new L. Once you get a new L, then again you run the same logic to find any other triplets are there with this F. Okay, so once this is done, so for the first number you added all the possible triplets. Then you go to the second number, right? So in this loop you'll go to the second number. While going to the second number, if it is same as the previous number, you need not do this. So you are skipping that, as I told you, right? Because for minus 1 you are already added all the triplets. Again, if minus 1 comes, right, you not do it. Okay, so so you're continuing the logic. Okay, so this is how you do it for all the numbers. The same logic you repeat for all the numbers, and all the triplets will be added to your resultant array, and finally you have to return the resultant array. Okay, so first you have to think of the logic, how you are going to do. So the idea behind the logic is so simple, right? From the code, right, have 3 pointers, right? Run the first pointer, this is A, the value is A, and the index is I, and second pointer is L, and the last pointer is R, right? After this, just add all the index, right? After sorting, add all the index. If the value is greater than 0, move the R this side. If the value is less than 0, move the L this side, so that you find the triplet. Okay, until you get a new L, here you have to move the L until you get a new L, and then repeat the same thing. So with keeping this as a first pointer, you added all the triplets. Then move your first pointer here. Then your L will be here and R will be here. Do the same thing, right? So that you find all the triplets and add it to it, and finally return your response. Okay. So let's run this and see. Okay, it has passed. Okay.